Hello, everyone. Um, Thank you for joining us today. My name is Shirin Bhambhani. I'm a senior solution architect at Amazon Web Services. I'm joined today with Shubham Dhoka. He's a senior cloud consultant here at Amazon Web Services. And we're going to be talking to you about DevSecOps strategy on AWS today. So this is going to be our agenda for today. We are going to give a brief overview of what DevSecOps is. We'll then talk about implementing DevSecOps. We have an architecture walkthrough, and then we'll wrap up with some key takeaways. What is DevSecOps really? Before we understand DevSecOps, we need to understand a little bit about DevOps. And DevOps is basically where you have two competing forces, which is development and operations coming together, right? Uh, and they come together in order to really drive business goals to fulfillment with very high agility. What these business goals can look like. They can look like new software versions, new releases, new applications. And when the two teams work together, they're able to build the software faster and keep it more stable. Now, over here, there is going to be a third force, a third competing force, which is going to be security now, whose main goal is basically to make sure that the software being developed, the organization's data and applications, everything is more secure and is being protected from any potential threats or vulnerabilities. And now these three competing forces together make DevSecOps. Just defining what DevSecOps is. DevSecOps is basically achieved by integrating and automating enforcement of security controls into the software development lifecycle. And when you integrate these processes and controls early on in the software development lifecycle, you basically ensure that they get validated consistently. By the increased collaboration between these three teams, between development, operations, and security, you are going to make sure that any requirements that they have any requirements that they have, any best practices that they have, they're all in alignment about that. And with that, they're doing all their automation correctly. So the automation would be not just infrastructure as a code, not just application as a code, but also security as a code. So all of this in 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 a collaborative fashion is what is going to make sure that the software features, the application products that are being deployed for the customers are being delivered in a very agile manner, in a very speedy manner, which is going to add value to the business. How do they achieve that, right? How do organizations achieve that? The organizations are able to achieve that by having a shift left approach. Shift left testing approach is basically where you start thinking of the requirements, start thinking of security in the requirement stages itself. And this will make sure that if there are any bugs, if there are any issues or any security incidents that could potentially happen, they get addressed much earlier on in the software development life cycle rather than getting addressed towards testing or towards deployment. So the cost of fixing a bug gets substantially reduced because you are going through the testing much earlier because you're starting to think of security through the requirements phase itself. So it's more of a cultural shift, a people and processes shift, because now you want to make sure that your entire organization is thinking of all of this since the start. And technology changes will follow automatically. With this cultural shift, you will get better CI/CD pipeline integration mechanisms. You start thinking of security and compliance tools much earlier on in the software development lifecycle, and that solves for your security issues later on. I'm going to hand it over to Shubham to talk about some of the DevSecOps implementation strategies.
Thank you, Sharon. So now that we have a better understanding of what DevSecOps is, let's look into how we can implement this for our organization. For the purposes of this session, we assume that you're using CI/CD pipelines at some extent in your existing organization. So how exactly do we integrate security into our pipeline? To do this, there are two major components. Next slide, please. The first component is security of the pipeline. This component focuses on having a secure infrastructure for your pipeline and the environment within which it lies. The second one is security in the pipeline, And the goal with this component is to have various security checks integrated into your software development lifecycle process. Let's look at this in a little more detail. The first component is security of the pipeline. If you're running a CI/CD pipeline in your environment today, I would encourage you to evaluate that pipeline against these five pillars to ensure that it's secure. The first one being identity and access management. With identity and access, we want to ensure that both people and automation within our environment have permissions that are fine grained and ones that follow the principle of least privilege. In addition, we also want to make sure that any builds happening within the pipeline are encrypted at rest, and communication with the outside environments is encrypted in transit. In addition, if you're downloading packages outside your environment, check for integrity before you download them as a part of your lifecycle process. Under governance and auditing, ensure that you have centralized controls or protective controls to prevent users from making or running unauthorized changes within your environment. Under auditing, keep a detailed audit log of all activities happening within your environment with details around who made the change, what was the change, and when did it happen. This will allow you to go back and investigate in case there is a breach that happens. In addition, have detailed logs and monitoring for all the different setups and metrics of your pipeline so that you can take actions on pipeline failures or critical events like pipeline deletion, etc. Last but not the least is pipeline as a code. It's very important to build your infrastructure as a code as it allows you to not just consistently deploy the pipeline checks across environments, but also scale your infrastructure and accelerate the deployments. In addition, if there is an issue that goes into your setup, having a versioned infrastructure as code allows you to roll back in case an error happens. Next, please. Coming to security in the pipeline, as a part of your lifecycle process, there may be various stages that you run through. For the sake of simplicity, we've divided it into the six stages seen on your screen. The first one being local development. As they say, charity begins at home. Same is true for security. Right in the authoring phase, I would encourage you to integrate various security checks, code quality checks as a part of pre-commit hooks within your setup. Any change that gets pushed will be scanned for these checks even before the changes are available in the source control repository. Moving on to the source stage, enforce at least two-factor review process so that all changes going in for your release branches are reviewed and verified before they are a part of the release. In addition, enable protection on your release branches to prevent any unauthorized commits or changes being pushed to it. In the build stage, use the principle of trust but verify and rerun all those quality checks and scan during this phase. In addition, you can also run software composition analysis, which is essentially running scans on any third-party dependencies that your application uses so that you have the confidence that these are secure and okay to move forward with the deployment. Going into the beta phase or beta test stage, you will deploy the first version of your environment here. And this is where you want to first ensure that the application functionality is as expected. You can run various sorts of tests here, like integration tests, acceptance tests, or regression tests. Going forward into the Gamma environment, we will run additional set of security scans, also known as dynamic application security scans here. You can use tools like um, OWASP, ZAP for these kind of scans. This will help you determine if there are software-based vulnerabilities in your application and if they are prone to web-based attacks like cross-site scripting, SQL injection, etc. As you move towards the production stage, you can continue to run monitoring and alerting on the critical metrics for your application. In addition, you can also run synthetic tests to simulate real user traffic and detect errors even before a real user comes across them. Let's take a look at a reference architecture that encompasses both of these components in AWS. So here's a reference architecture with a CI/CD pipeline running DevSecOps tools and services within it. If you're running, you know, if you're running an environment that is that uses separate set of tools, for example, Jenkins, you can replicate similar setup within your environment. For the purposes of this architecture, we are deploying a web application to AWS Elastic Beanstalk in two environments, that is staging and production. Elastic Beanstalk is a managed service for deploying and managing applications in AWS. And the process for this deployment goes yeah, goes as given below. So here's how the process works. At first, whenever a developer makes commit or code changes to the application, after the pre-commit hooks run scans, these changes are available in the source control repository, which in this case are AWS code commit. Once these changes are available in the source control system, they move to the next stage, which is the code build. This is where we would run additional scans and quality checks on this code base. We will use static scanning tools for security like SonarQube, or if you're running PHP, you can run PHP scan. If all goes well, the process will move to the next stage. If there are errors, the pipeline will abort and alert the appropriate owners on the failures. In addition, the findings from these scans will also be published to AWS Security Hub, which provides you with a single pane of glass access to all the security findings and errors within your environment. As you move forward, your code will be deployed to your code will be deployed to the first environment in this first staging environment. Once that's deployed, you can run additional scans using dynamic application security testing via tools like OWASP here. And similar to before, the findings from these scans will be published to AWS Security Hub. If all goes well, you'll move forward. If there's a failure, the pipeline will abort and alert the appropriate owners. Next, assuming we have a successful scan, we can move on to the manual approval phase, which has a quality gate of getting an approval from business owners or pipeline owners before it gets deployed to production. Finally, once it's deployed in production, we continue to monitor and have alerts so that uh, we are alerted on any issues, breaches, or security related errors. The pipeline, the infrastructure itself is made secure using various components. I'll list a few. The first one being a minimal use of permissions, only as needed for both people and automation uh, within this environment. In addition, we have a detailed audit log of all the activities happening within this environment using AWS CloudTrail. And we have some additional checks to detect injection of secrets and other core items using AWS config rules. Hope this helps you provide a high-level reference into how you can go about integrating security and various checks as a part of your software development process. Next, please. Sum it all together. The infinity loop nature of this diagram basically represents that DevSecOps, or integrating security within your application lifecycle, is an ever-evolving process. As your organization continues to mature, you can add additional security checks and scans as a part of your application lifecycle to make it even more robust. Right. With that, I'll pass it on to my colleague Shirin to discuss the key takeaways.
Thank you, Shubham. So we'll just see a couple of key takeaways from our discussion today, and then we'll wrap up our session. Um, Basically, as we discussed, it's a cultural and technology shift. As Shubham discussed, the technology details of security in the pipeline and out and of the pipeline. There are a lot of tools available for making sure that you're testing and monitoring everything at each and every interval. And that is possible if you automate everything in order to get correct notifications, scanning tools, and all the different features of the technology part of the DevSecOps model. For the cultural part, we spoke about how the shift left testing is basically more of a mindset change, more of a people and processes change, so that teams work as one unit in order to support business goals, in order to support creation of more products and features in a more agile fashion. So with that, we'll wrap up for today. Thank you so much for listening to us. Hopefully you learned something good. And hopefully you'll be able to implement some of the best practices we discussed today. Thank you.
Everyone.